Okay, so in this next unit, we're going to start taking a look at absolute value. We use absolute value to measure distance. So if we take a look at this number line, we want to find out what's the distance between -2 and 5. Well, here's what we can do. We can just say, what is the distance between -2 and 0? And we know that that distance is going to be 2 units. Then we can also do, what's the distance between 0 and 5? And the distance there is 5 units. So we know that the overall distance is going to be 7 units. Now what we can do to express this is we can say 5 plus the absolute value of -2. So we've got our point here 5 and we've got our point here -2. So this would become 5 plus the absolute value of -2 is 2. And so you can see that we've got a distance of 7. Now what I've done here is I've put up 4 examples to show how absolute value is going to react based on whether we've got a positive or a negative on the outside of the absolute value. The one thing that you do want to know is that whatever is inside of the absolute value is going to become positive. So if we've got the absolute value of 7, that's going to be just 7. Since there's a positive on the outside, we're going to leave it as 7. The absolute value of -7, again, anything that's inside of the absolute value is going to become positive. And that's once you work everything out, once you've done order of operations inside. So the absolute value of -7 is 7. Now coming down here to negative absolute value of 7, what we would do here is we would say we've got a -1 on the outside. That's what this negative stands for. It's in -1. Then the absolute value of 7 is 7. So we drop the absolute values, and now we have a positive 7. But now we've got to take care of this -1. So -1 times 7 is -7. Then down here on the bottom, we again have this -1, what is assumed to be a -1 here. So -1 times, and then the absolute value of -7 is 7. So again, we're going to get -1 times 7, and that's going to give us -7. And that's the difference between when you have a positive on the outside versus when you have a negative on the outside of an absolute value. Okay, we're going to look at how absolute value can be applied to baseball. So let's say that we've got a pitcher standing on the mound that is 60 feet 6 inches away from home plate. And the batter is going to take a swing, and the ball is going to go straight over the pitcher's head to deep center field for 400 feet. Then the ball is going to be thrown back from the stands because this is Wrigley Field and that's what they do. And they're going to throw the ball back onto the field, and the ball is going to make it back to the pitcher's mound. How far did the ball travel? So what we're looking at here is we've got 60 feet from the mound to the plate. Then we've got 400 feet going back into the stands, and then the ball is going to return 340 feet to the pitcher's mound. So what we're looking at here is we want to figure out how far did it travel. We know that it's going to travel 0 to 60 right here. So there's 60 units right there. Then from home plate to the fence or to the stands, it's going to travel 400 feet. So we know that there's a distance traveled right there of 400 feet. And let's say that this is -400 right here, because we'll say that the positive is going towards home plate, the negative is going towards the stands. Then it goes from whoever caught it in the stands throws it back onto the field, and it makes it back to the pitcher, and the pitcher's standing here, so that is going to travel a distance of 340 feet. So what we want to do is figure out how far did the ball actually travel. So starting from the pitcher's mound to home plate, 60 feet, plus from home plate to the stands, -400 feet, and then back to the pitcher's mound, plus 340. So we got 60 plus the absolute value of -400 plus 340. So go ahead and take care of the absolute value first. So we get 60 plus 400 plus 340. So 60 plus 340 is 400, plus another 400 is 800. So the ball traveled 800 feet in total. In our next set of problems, we're going to work with a little bit more complex absolute value. So what we're looking at in this first one is the absolute value of -7 plus the absolute value of -5. Now, what you want to do with these absolute values is you want to treat them as if they're parentheses. So anything that you have to do inside of the absolute value, you're going to work on that first. Then once you have that solution, then you'll start working on anything that's on the outside. So if we look at this first one, absolute value of -7 and the absolute value of -5, we can work on those independently at the same time. So we've got the absolute value of -7 is going to give us 7. Then we've got a plus, and the absolute value of -5 is going to give us 5. So now it just comes down to 7 plus 5, which is 12. On the next one, we have the absolute value of -7 minus the absolute value of -5. So for this one, again, we're going to work inside the absolute values first, and then we'll do anything that's on the outside. So we have the absolute value of -7 is 7, then minus the absolute value of -5, absolute value of -5 is 5. So what we end up with here is 7 minus 5. 7 minus 5 gives us 2. And then finally, we're going to work a little bit more with a longer order of operations question here. So again, start with the inside of the absolute value. -7 plus 3 is -4. Now you don't want to go changing that -7 to a +7 because you've got to work whatever's inside of the absolute value first. Once you've simplified the inside of the absolute value, then you can take the absolute value of whatever's inside of it. So 3 times the absolute value of -4 minus 2 squared. Now these absolute value signs still act as if they're parentheses, so we're going to do this first. So we get 3 times 4 minus 2 squared. Now that we've gotten rid of the parentheses, we just continue on with PEMDAS, and we're going to look at exponents. So 2 squared is 4, so now we've got 3 times 4 minus 4. Once we've done exponents and radicals, move on to multiplication or division. 3 times 4 is 12. And then do any remaining addition or subtraction that's left. 12 minus 4 gives you 8. And that's how you do order of operations with absolute value. All right, so the last thing that we're going to do for this section is go back to absolute value on a number line. So you do want to know this formula here. This is the distance on a number line is equal to the absolute value of a minus b. And the reason why I have this NL down here as the subscript is because later on you guys are going to learn distance on a coordinate plane as well. And they are two very different formulas. But they both start with a lowercase d. So I always put the NL as the subscript just to indicate that this is a number line as opposed to the coordinate plane. In this problem, we've got a coordinate of -5, that's our a value, and then we've got a coordinate of 6, which is our b. So all we're going to do to figure out what is the distance between these two is take these two coordinates and plug them into our equation. So we've got the absolute value, d equals the absolute value of -5, oops, put that in as a parenthesis, then minus 6, and then close off the absolute value. So we know that we've got -5 minus 6, so -11. So -11, so we have the absolute value of -11, the absolute value of -11 is 11. So there's 11 units in between A and B.